is Allison. Thanks for letting me do this remotely. I'm going to talk about lipoproteins and cholesterol today. So we're going to go over the movement of lipids because they cannot travel through the bloodstream as they're hydrophobic, and so they need carriers, which we'll talk about the pathways which involve lipoproteins. This involves the exogenous pathway, which is from the intestine to the liver, and then kind of a second chance for tissues to reabsorb, which is the endogenous pathway, which is from the liver, again, giving it a second chance. And then we'll talk about cholesterol metabolism. So there are 5 lipoproteins that are important to us. We have the chylomicron, which is this larger molecule that comes directly from the enterocytes, which are the epithelial lining of the small intestine. They go through the bloodstream, then we end up with this VLDL. So notice these green things are apolipoproteins, which are kind of receptors. The yellow are the triglycerides. The blue are cholesterol esters. So we have mostly triglycerides here and here. And as it goes through the bloodstream, they get smaller. And then until you get to the LDL, which is now almost exclusively cholesterol esters. That there are not exclusively cholesterol esters like this depicts, but are mostly. HDL plays a unique role, and we're going to talk about that later. So this is what a nascent HDL looks like. This is what it looks like when it's added, kind of what it's meant to do, and we'll talk about that later. The exogenous pathway is from the intestine after we eat some food. The pancreas lipase enzymes break down triglycerides into fatty acids and monoglycerides. I thought it was interesting to note that you do not lose the glycerol. It is still attached, but it does need to be broken down. And then the liver excretes bile acids, which form these micellar. And so once you have that, it can be kind of absorbed into the enterocytes, but that is not alone. Oops, that was a question for later. These fatty acid transporters are needed to absorb it. And then through the Golgi apparatus, they're packaged into the chylomicrons. And from there, ApoB48 is added, and that's what allows it to secrete into the lymphatic system. So, why are triglycerides broken down only to be reformed again? And I'm going to give you some time to answer this. Okay, well, I hope that space wasn't awkward, but they have to be broken down to enter the cell. They cannot enter the cell without the smaller. They're like too big to enter otherwise, and so they're reformed and packaged. And once they're packaged in these phospholipids, they can exit. Okay, so the exogenous pathway then goes on to, okay, so here we got our chylomicron that just went out. It goes through the lymphatic system. And so at this point is still a nascent chylomicron. To make it a mature chylomicron, it has to be added these 2 proteins, which I went over here, is the ApoE, ApoC2. So these are added by HDL. This HDL molecule over here adds it to the chylomicron. It travels through the capillary system, and then the ApoC2 is what is necessary for it to interact with this lipoprotein lipases. So these kind of like allow it to absorb some of the fatty acids, and then it moves on. So this is still in existence, and it moves on, and now it's called a remnant. So as it gets depleted through the system, it's a remnant and then gets returned to the liver. So the ApoE is what allows it to return to the liver and interact with the LRP and LDL receptors. And then, oh, I forgot to show this. So this is what, I thought this was a better picture of what a chylomicron looks like. So we got the phospholipids, the proteins, cholesterol esters, and the triglycerides. So, is a chylomicron in the lymphatic system mature? Why or why not? So, as we talked about earlier, here's the chylomicron. This ApoE is not actually here, but it is in this picture, but it's actually not. it's added by the HDL. And so when it has this ApoC2 and the ApoE, that's when it's mature, and that doesn't happen until after it's in the capillaries. So the endogenous system occurs kind of second chance around, and this is after the liver. So the liver packages these things into VLDLs, very low density lipoproteins is what it stands for. I think you guys know that. But this is a nascent VLDL. It has the B100, it has triglycerides and cholesterol. In order for it to be mature, it has to get added the ApoC2 and the ApoE, just like a chylomicron from the HDL. So those two guys are added. Oops, these two guys are added onto here. So the C interacts, it loses some of its triglycerides, and then it is an intermediate density lipoprotein. So as it loses these as it loses these triglycerides, it has a lower triglyceride content, a higher cholesterol content. And as we'll talk about on the next slide, this cholesterol content isn't just a ratio higher, it's actually being added by the HDL, scavenger HDLs to these. So it's actually going up in cholesterol and down in triglycerides. So the ratio, until it's to the point that it's almost exclusively cholesterol, at that point it loses its E, it loses its C, and now it just has this B100, and that B100 kind of acts to work with LDL receptors and delivers now at this point cholesterol to extrahepatic tissues. So if it's still in the bloodstream, hasn't found anything to take up its, then it goes to the liver. Now we have to talk about HDL scavenging. So HDL molecules are secreted by the liver. So at this point, the VLDL is secreted. IDL and LDL are products of VLDL, so they're not secreted by the liver, but VLDL is secreted by the liver and HDL is secreted by the liver. So we have our HDL nascent. That's because it does not have any cholesterol esters yet. So this ApoA1 is what allows for the LCAT to work. So what that molecule does is it takes the cholesterol and turns it to cholesterol esters, allowing it to become a mature HDL. So it's getting those cholesterols from macrophages, from different peripheral cells that have too much cholesterol, and then it also gets extra cholesterol from the VLDL and chylomicrons being this cholesterol ester transfer protein. So these are transferring over here, so now this is more, and then it returns that extra cholesterol to the liver via these SRBI transporters. So why is HDL scavenging essential to the body? The end game is HDL is important to the body because it is your only chance at a kind of third strike, you're out kind of thing of getting your cholesterol a second chance at getting redistributed to the body. So once it's in the liver, it gets repackaged in here and gets a second chance at going somewhere rather than just building up where it doesn't need it. Maybe there's another cell that needs it. So cholesterol metabolism. So our body will take in these cholesterols via the LDL, and then, it goes to the endosome, all these things we learned. And then, okay, well, now we have a lot of cholesterol. But what if we have too much cholesterol? Well, we'll store it for a while, but then after that, you have to inhibit synthesis of cholesterol because we're not just taking it in from outside sources, it's also being synthesized. So it will decrease transcription, it will inhibit the activity of HMG-CoA reductase. So that's kind of your key enzyme in synthesis. I didn't get too much into this. I would go over Dr. Rosenberg's lecture for more information, but this is kind of the enzyme that you want to remember, and it's also the enzyme that statins inhibit. So excess cholesterol is then returned to the bloodstream via bile acids, which help ironically absorb fats, but and then if we have too much bile, it can be returned to the liver and resynthesized into cholesterol. So we got all these backups. So here's the summary. I don't want to go over this because I feel like I'm over time. And these are my senior photos. This is kind of my senior photo, and this is actually at graduation. So I grew up in Marquette, Michigan. Well, I didn't just grow up there, you know that, but I went to high school in Marquette, Michigan, but for 2 years, and I was an athlete, so I was really committed to staying an athlete until I got a stress fracture, and then I was like, okay, let's do the music thing. And then I went to boarding school. Yes, I went to boarding school for music. So it's kind of intense, and that's my graduation from this school, which was in Interlaken.